If I take these two examples, when I'm saying that 1, 3 is overlapping with 2, comma 3 and it is also overlapping with 1, comma 2, what is my basis? If I just plot like this, 1 p.m. to 3 p.m. my time slot is booked. So, sorry, the 2 p.m.s will come somewhere over here. So my slots are 1 to 2, and I have 2 to 3. And my another slot is 1 to 3. So, of course, it is overlapping. But mathematically, what is the basis? Hi everyone, welcome to my channel Code with Ease by Varsha. Today we will talk about this Leetcode medium question, the non-overlapping intervals. So this is an intervals based question. Out of the playlist over here, we have already done 2 questions on intervals. Intervals is like a coding pattern, so to say. So non-overlapping intervals will be the third question as part of this playlist. So please check out the initial 2 videos to understand this better. Intervals in simple terms can be thought about like the start and the end time, like a time slot, the starting time and the ending time slot. For example, like you have a meeting from 1 p.m. to 2 p.m. So 1, comma 2 represents that particular meeting slot that you have. So this is how I like to simplify the intervals in a more real world kind of a thing. So what we need to do in this question is something very simple. We are given an array of intervals where the intervals represent the start and end, like we said. We need to return the minimum number of intervals that we need to remove to make rest of the intervals non-overlapping. So this is a new keyword that we have. How do we make it non-overlapping? So what is overlapping, by the way? So you have a meeting room which is booked from 1 p.m. to 2 p.m. Great. You have the meeting room booked from 2 p.m. to 3 p.m. Great. These two are disjoint, mutually exclusive, discrete meeting slots. They are not intertwined or they are not overlapping with each other. 1 p.m. to 2 p.m. is one slot, and then you have another slot from 2 to 3. Great. But if you have the meeting room booked from 1 to 2, and then you have another slot which is booked from 1 to 4. So 1 to 2 and 1 to 4 are overlapping. So this is what is being meant by overlapping, and then of course the opposite is non-overlapping. So if you are given this, if you see this example, 1, 2, 2, 3, 3, 4, these three are mutually exclusive intervals. There is no overlap. But 1, comma 3 is overlapping. So 1, comma 3 is overlapping with 1, comma 2, and it is also overlapping with 2 and 3. And what is the minimum number we can remove? The least what we can remove is 1. The least what we can remove is just 1. So we have to remove 1, comma 3, and that is why the output is 1. If we see the second example, all three are overlapping with each other. What is the minimum number we can remove? 2. Then we will only be left with 1, comma 2. In the third example, we have 1, comma 2 and 2, comma 3. So we have nothing to remove because these two are disjoint. They are not overlapping with each other. So what we need to return is the number of intervals. So we can have some kind of a counter basically, and if we can figure out that if an interval is actually overlapping, and if it is, we have to remove it. So in this case, what we can do is if an interval is overlapping, what we just need to do is we have to increment that counter if it is overlapping. And ultimately, we have to return that count. So that is the basic skeleton of how it should look like. So these are the intervals that we have taken from the example. We have to return this count variable. How do we figure out, how do we increment this count? That the answer to that can be got when we know how can we detect if a certain interval is actually overlapping. So that is what we have to figure out. So if I take these two examples, when I'm saying that 1, 3 is overlapping with 2, comma 3 and it is also overlapping with 1, comma 2, what is my basis? If I just plot like this, 1 p.m. to 3 p.m. my time slot is booked. So sorry, the 2 p.m.s will come somewhere over here. So my slots are 1 to 2, and I have 2 to 3, and my another slot is 1 to 3. So of course it is overlapping, but mathematically, what is the basis? The basis to find out, we have to remember one thing, that these are always denoting the start and end pointers. So if you compare the end pointer and the start pointer, you will probably get an answer. Okay, so what we need to compare over here is, see, 2 and 3, 1 and 2 are the ones which is mutually disjoint, discrete intervals. Now, if you see, the start pointer of 1 and 3 is 1. So I'll just write like this, 2 and 3 is here, 1 and 2 is there. What is the end pointer of 1, comma 2? It is 2. But 1 is smaller than 2. 1 is also lesser than 3. So whenever the start pointer of some interval is lesser than the end pointer, we can safely say that it is overlapping. This is the basis that because start pointer is lesser than the end pointer, they are overlapping. Now if this is the assumption, now let's try to do a dry run and see if this is perfectly valid. What is my end pointer initially? It is 2. Is 2 lesser than 2? No, it is not. So they are perfectly fine. Okay, is 3 lesser than 3? Because this is the start, this is the end. We are comparing the start of the next interval or the current interval and the end of the previous one. Is 3 less than 3? No, it is fine. Great. Is 1 less than 4? Yes, it is. So now in that sense, 1 and 3 looks like there's a problem with this and we need to remove. So we can say count plus plus. But this also works fine because we know that this is the one which needs to be removed. We have already discussed in like beforehand. Suppose these two were not there. Okay. Suppose these two were not there. We only had this much. And we had our intervals 2D array as 3 and 4 and 1 and 3 in the same order. In that case, what would have been the case? In that case, our theory would have been proved wrong because 1 to 3 and 3 to 4 are not overlapping. They are mutually disjoint. But what our theory is saying, whenever the start is lesser than the end, we will say that it is overlapping. So in that sense, your 1 is lesser than 4. Then where is the problem? There is some problem, right? So our problem is we are not sorting the intervals. We have to sort the intervals based on their end pointer or the end value, whatever you might call. So if you do that, what will it turn out to be? It will turn out we will have 1 comma 2, we will have 1 comma 3, we will have 2 comma 3, and then we will have 3 comma 4. So like we said, we have already sorted the intervals based on the end pointer. So now we have the end pointers in ascending order 2, 3, 3, 4. So now the question arises, why do we need to do this? What will happen if we don't do it? So imagine, like we said, 1, 3 is there and 3 and 4 is there. Now what happens if we actually sort it? When we actually sort it, 3 and 4 comes in the right order. But I mean to say, like if the original was 3 and 4 and 1 and 3, we were wrongly seeing that 1 and 3 became overlapping because 1 is less than 4. But when we sort it, 3 and 4 is like this is the end pointers correctly sorted. Now when we check the start and the end pointer, 3 less than 3, is it true? It is not. So that is why 1 and 3 and 3 and 4 will come out to be non-overlapping. The count pointer will not be incremented. Now come back to this dry run which we have where we have arranged it in the sorted it in the basis of the end pointer. Now what is going to happen? So now over here, this is my start and end, right? So my end, the start pointer is going to be compared with the previous end pointer. So is 1 less than 2? Yes, it is. So now this is a potential overlapping interval. So my count, which is initially 0, now it will become 1. So we've got one interval which is overlapping. So now we move ahead. Remember, whenever we are incrementing the count, we are not changing the end pointer. So end pointer will remain over here. I check to this interval. 2 less than 2. Is 2 less than 2? No, it is not. Whenever it is not, then my end pointer will change to my current interval's end pointer. Again, I move ahead. Is 3 less than 3? No, it is not. I will again change the end pointer to this and exit the loop because my intervals have exhausted. The point we are trying to make is whenever this condition is coming out to be true, as the start is less than end, it is overlapping, our count will be incremented. But whenever this condition is not true, we move ahead because we move ahead, our current interval becomes the current interval's end pointer becomes a point of reference to check it against the next interval. Okay. So just to summarize, what are the steps that we have done? Firstly, we'll have a count, a pointer initialized to 0. My end pointer is going to be my current interval. I mean the first interval's end pointer initially, because later on we'll change. We'll traverse the array. Third step. Traverse array using a for loop. Inside this, what do we check? If that s less than e. Now s less than e as in the current interval's 0th pointer and the whatever end pointer you already have. If this is true, my count will be plus plus. The same code is already there in the GitHub, the Java code. I'm just writing the pseudo code. Else, what we are going to do, our end pointer is going to change to my current interval's end pointer. Okay. And we exit the loop. After that, finally, what do we need to do? We just have to return our count because we need the number of intervals. This is what we have to do. These are the steps that we need to do. So it's important to understand what we are doing in every step, and it is also important to understand why we are doing that in that step. That is the basis, that is the reason for doing this dry run and explaining the intuition and the thought process. So that is all about this question. The code is available in the GitHub as I have mentioned. So please check it out, and do let me know if you have any questions in the comments. Please don't forget to subscribe to my channel and click the notification bell to never miss an update. The more and more you guys subscribe to my channel, the more and more valuable content I will be able to bring in the future. So please do subscribe, and thank you so much.